Okay, now let us take another 2006 problem which says that if the expansion in the power of x of the function is y1 minus bx is given to be equal to a0 plus a1x plus a2x square and so on, then you have to find the value of the an, that is the coefficient of x raised to power n in the question. So now let us see first of all what do you mean by the function that is given to you 1 by ax and 1 by 1 minus bx. So I can write it down as different multiplication of two functions, that is 1 minus ax upon 1 minus bx, or I can write it down as 1 minus ax raised to power minus 1. Alright, this is minus 1 over here. So now you will have to learn the formula for the kind of series of expansion. Let me change the pen once again. Of the type 1 minus x raised to power minus 1. So this is nothing but 1 plus x square plus x cube, and now this becomes an infinite series. So this is the formula that we are going to use in this question. Okay. So using this formula, this can be implied that 1 minus ax raised to power minus 1 would be 1 plus ax, 1 plus a square x square, 1 plus a square x cube, a cube x cube, and so forth. And similarly, applying the same logic, 1 minus bx raised to power minus 1 would be 1 plus bx plus b square x square plus b cube x cube, and so on. Now you have to multiply these two terms, alright, because since these are multiplied in the paper only, so we have to multiply these two terms, and we have to multiply in such a fashion because we need to find the value of x raised to power n. Okay, so let's see how to do this one. So you need to multiply it in a fashion such that you find the in the left hand side you want the coefficient of x raised to power n only. Okay, so how could we get this thing? If I multiply the constant term of this with the x raised to power n term of this, where x raised to power n term will be bn over here, so that means first term I can write as bn. Okay, now if I take x over here, I need to get what? X raised to power n minus 1 over here, which is a times b raised to power n minus 1. Similarly, if you can comprehend, what I'll get? A square into b raised to power n minus 2, and this series will go on till I'll get complete an, because the last term over here will be an raised to power this will be an xn, and I need to multiply this with the constant of this. Okay, so this is basically the coefficient of x raised to power n, or you can say this is equal to an. Now if you see properly what it is basically forming a GP with the starting term as a as bn, and what is r over here? R is again easy to find. This is a by b in this case, and the number of terms are n. So you need to just find the sum where what's the formula? A into 1 minus r raised to power n upon 1 minus r. That is the formula that we have to use now. Okay. So now, but one more important point over here is that I have written that total number of terms will be n, which is wrong. That is I suppose the main important point of this question. The number of terms in this expansion will be n plus 1. Now why this will happen? Because you have a term which is 0, you will have a term which will have an. So if you see, you have terms from a0 to an, because if it is b raised to power n over here, that means I can write it as like this. So it is ranging from a0 to an, so that means n minus 0 plus 1 are the total number of terms. That means total number of terms are n plus 1, not n. So this was the main point of this question, highlight of the question you can say. So now just apply it in the question. So this is b raised to power n 1 minus a by b raised to power n plus 1 upon 1 minus a by b. So this becomes b raised to power n into b raised to power n plus 1 minus a raised to power n plus 1 by b raised to power n plus 1 of this side, and this will be b minus a further b. So this whole will get cancelled out and you will be left with only b raised to power n plus 1 minus a raised to power n plus 1 upon b minus a. So this is the answer that you are going to get. So now if you look out in the options, it says option D. So that implies option D was the correct one in the paper. Okay, so again it was not an easy problem, but could have been solved in the paper if you just apply your brains. And the main point that I have already mentioned is that the total number of terms are n plus 1, not n in this case. Okay.